We are Team Brainstems. We're working on brain tumor classification and MRI scans. Our main goal is to analyze these brain scans and figure out whether the depicted brains in the scans have a tumor or not.
We were able to use a high precision data set with a good resolution of the image. There was actually not much additional data cleaning required. We used two different networks to analyze this information. One was a classical CNN. We started off with the input image as a matrix, applied several filters. Then we ran this through several convolutional layers and used max pooling to reduce the image size. Finally, using flattening, we were able to come to our conclusion of whether there is a brain tumor or not. This was our baseline. Second, we had the autoencoder. This would be our comparison. First off, we again put in the images, then we first performed the max pooling. We arrived at a low dimensional representation and finally applied several deconvolutional filters on this image. This reduced the resolution and changed the images in such a way that they could serve as a different input towards the CNN.
Using Google Colab, we split our data into training and testing data 80 to 20 ratio, and we created an autoencoder that reduced feature dimensionality. This autoencoder used adaptive optimization and mean squared error loss function, a common regression loss function. We then fed the autoencoder output into the convolutional neural network and then compared those results with the CNN model trained on non-autoencoder image data. The CNN model used binary cross entropy or log loss, which is a common classification loss function. The CNN model used 110 epochs in training and 94 epochs in testing, and the autoencoder model used 110 epochs for training and 20 epochs in the convolutional neural network. We decided on these epochs by using the ELBA method, which is a clustering method that consists of plotting the explained variation as a function of the number of clusters and picking the elbow of the curve as a number of clusters to use. Performance metrics. Our CNN model at the final epoch 94 showed a loss value of 0.1603 and a validation loss of 0.1652. Our autoencoder model at its final epoch 20 showed a loss value of 0.0056 and a validation loss value of 0.0057. From this graphs on the side, you can see that both models showed decaying functions when displaying the loss values over time and an exponential function for the accuracy over time. So we know that accuracy improved and the loss value went down for both models, and they're both effective. Insights, challenges, and next steps. An insight we weren't expecting was that our convolutional neural network model outperformed our autoencoder plus convolutional neural network model. This brings with it a challenge that we want to improve our AE performance and are surprised that it didn't do as well as we had expected. So our next steps are to locate the tumor within the brain by running algorithm on subsections of the MRI scan, improve our autoencoder convolutional neural network performance. Thank you.